So as we saw last video, a normal vector is going to be normal to any vector in the plane. So if I know a point on my plane, I can say that point P on my plane, x, y, z, is connected to this point with a direction on the plane. So I could say that direction is going to be x minus 3, y minus -1, z minus 2. And I know that d dot n is going to be equal to 0. So I can set this up. X minus 3, y plus 1, z minus 2, dotted with -2, -1, 7. Let's make that more like a 1. So that's going to be -2x minus y plus 7z. And now I'm going to go back and do all of these. -3 times -2 is plus 6 minus 1 minus 14 equals 0. So -2x minus y plus 7z. 6 minus 15 is minus 9 equals 0. So let's go look at this in our GeoGebra link. So this is example 5. So I can come into vector examples and look at example 5. Maybe. Okay, here we go. Example 5. All right, so here's what I've got. And if I want to input something, then I need to open it with GeoGebra. So here is my point that I was given, and then here's my normal vector. I just made us a multiple of it to make it smaller. So I did 2/7 to make it smaller. So there's my normal. Here's my point. So I said that I thought the equation of the plane was -2x minus y, I believe. What did we say? Minus y plus 7z. So it wanted to make this a point. Let's not let that happen. Plus 7z minus 9 equals 0. So, wow, GeoGebra is frustrating. Oh. All right, so -2x minus y plus 7z minus 9 equals 0. And there's my plane. And now we can see that if we move this around, my point A is on the plane, and here's my normal vector, and I can see that it definitely looks normal to the plane. Also, looking at this, I can clearly see that my point B is not on the plane, and that's the other part of this question. We're asked, does this point lie on the plane? So I can just test it. So I'll switch colors here to test. All right, so we've got -2 times 3, -1 times -1, plus 7 times 5, minus 9. Does that equal 0? Well, -6 plus 1 plus 35 minus 9 definitely does not equal 0. Therefore, the point is not on the plane.